been spotted.
Perfect! Charge and fire!
Wait, no! There are innocent civilians. Charge directly and we'll kill everyone. Go around and target the enemy directly.
Would it be great if we could be this precise in treating our patient's disease, either targeting the tumour cells or the disease itself and not affecting the healthy parts of the patient's body? I'm Tony Lim, Head and Senior Consultant at the Department of Anatomical Pathology at SGH. I also run the Polaris program at SingHealth. My team and I are like detectives. We find out more about tumours and diseases to find targets to treat them. We find out more about the disease characteristics through a method of molecular profiling. We then pass on this crucial information to the doctors for them to treat the patients. Let me illustrate. In cancer, for example, we look at the tumour cells to identify the gene that caused it. Doctors can then tailor the treatment according to the molecular profiling results. And this is better than chemotherapy because it is a targeted approach and does not kill the healthy cells. Let's see how this works with lung cancer. Researchers have previously identified some enemy suspects for lung cancer, genetic mutations known as EGFR, KRAS, and ALK. Yet some of our enemies have complex names. Each suspect has a unique set of characteristics, a preferred method of causing damage, and most importantly, an Achilles heel. The weakness of each enemy will ultimately determine the weapon, or should I say treatment or drug, that we can use to destroy it. To identify and understand the enemy better, my team uses different tools, and these include different pathology techniques. This allows us to look at the disease through a much more magnified lens. One of the techniques is immunohistochemistry, or IHC, which allows us to recognize abnormal cells in cancer tumours. Another technique is called fluorescent in situ hybridization, or FISH for short. It uses fluorescent probes to make certain features in the tumour more identifiable. Lastly, we use next generation sequencing, or NGS, which helps break down the tumour DNA and analyze genes individually. In the past, we were only able to look at 5 cancer genes at once. With these new tools, we can now study about 100 genes at one go. That's like assessing the profiles of 100 enemy suspects and pinpointing the exact one to destroy and stop the war without harming any innocent civilians in the process. By correctly identifying and understanding the enemies in lung cancer, we can now find gene mutations in up to 90% of lung cancer patients as opposed to 60% of them previously. This means less patients have to go through conventional chemotherapy, and in fact some receive treatments in the simple form of oral drugs that have the ability to fight specific cancer cells. In the future, we will develop new tools to look at different forms of cancer. This will include using patients' blood instead of biopsies. The detective work by pathologists is crucial in targeting and treating diseases effectively. There's still so much about cancer that we do not know. As we further our efforts, I believe that we will be able to help doctors tailor better treatments for the patients across a range of diseases. This will improve the lives of our patients.